Are you a podcaster? Maybe you've got that big idea and you're looking for a network to join. The multi-award-winning Ozcast Network can get your content to eyes and ears all over the world. Join now for the first month free, and you could be featuring this sound at the beginning of your podcast.
Ozcast.
Simply head to ozcastnetwork.com for details.
Thank you for downloading and listening to This Pathological Life. If you're interested in continuing the story, we have a second series called This Medical Life. Please download it and subscribe now.
Dr. Travis Brown, why do we need a podcast called This Pathological Life?
Every disease has its own story to tell. So we're going to tell them.
For the next part of this episode, we're looking at anaphylaxis. And I just have to ask one question, Dr. Travis Brown. I went travelling recently for work and I took a bag of peanuts with me, which I had opened to have some. And then, lo and behold, got back and they'd spilled. And in one of my zip flaps, it was full of peanuts, which I've dusted out and cleaned. But it just occurred to me, I probably should not be taking that bag anywhere in a confined space, because someone who does suffer from anaphylaxis shock, which can be triggered by peanuts, I believe, that could be a risk. It's
interesting. Yes, it can be a risk. One of the things that our guest has said is in some of his presentations is that even at schools where they would have completely banning products that people are allergic to is actually not good. And that's because it's sort of like taking it out completely of in the environment, sort of it's actually recommending people to avoid it as opposed to you just can't not have it. And so it's an interesting, so we would raise that with him and say, look, what is the recommendations? Yes, it should be cleaned, but again, it's one of those ones where you probably wouldn't lend it to a friend who has a nut allergy.
No. Can I just check if you do? Because
I don't have any nut.
I am actually sitting right next to that bag as we record.
No, I don't. I'm all good. But that actually brings us to anaphylaxis and the people who discovered anaphylaxis, if we want to call it that term. So this is people by the name of Portier and Richet. And so this was the important date here was 1902. And this was credited as the date an article went out of the discovering of anaphylaxis. So Paul Portier was born in 1866. So at this time he came out, he was about 36 years of age. Now he'd done a medical doctorate in 1897. And then went and became an assistant in a laboratory of physiology. Now, during this time, he met Prince Albert I of Monaco, and they got a friendship, and they shared an interest in marine biology. Portier was invited to go on a cruise in 1898 that turned out to be something like a science experiment, annual science experiment, where they would go on a cruise, and look, it was a widespread. And then they went on one in 1901. And then we have Charles Richet, who he was born in 1850. Now, at this stage, he was about 52 years of age. His background was had experience in chemistry, anatomy, physiology, pathology. And he was entering the field, or had already been in the field, of experimental physiology. He, at this stage, had 424 publications, so he was renowned. And he got an invitation to join the scientific cruise in 1901. So the cruise contained experimental animals, but they couldn't start their testing until they found the source of the tests. This is Physalia. This is Portuguese man-of-war. So they went looking for blue bottle jellyfish. Because the blue bottle jellyfish or Portuguese man-of-war, it's an organism that's made up of 4 polyps. It's the one that floats on top of the ocean and drifts with the currents, usually in the warm waters, and so it inflates, so it sits on top. But you have like a polyp that's involved for digestion, a polyp that's involved for reproduction, and then you've got these long tendrils or tentacles. The average length of these is about 30 feet, and it contains poison that normally paralyzes and kills fish, and then it draws it up and ingests it.
Mm-hmm.
People know about this. Sailors know about this because if they get stung, it's excruciating pain. It's rarely fatal for humans, but you very much know if you've been stung by one. And so they can drift in groups of up to 1,000.
Oh, boy.
So, and again, these tentacles are average 30 feet, but can be extended up to 165 feet. So they went looking for these Portuguese man of war, and what they found was a group of them 350 miles off the coast of West Africa. And what they were able to do was, using the tentacles, they were able to get a glycerol extract from the tentacles, which they called hypnotoxin, and it produced CNS brain depression in ducks, pigeons, guinea pigs, and frogs. But so they confirmed that yes, it had the poison in it, and it was able to induce it, and they were actually able to get it and do it themselves. But then, after these experimentation, Portier and Richet hypothesized, what happens if we do repeated injections of sublethal doses in experimental animals at increasing doses? Can we induce tolerance?
Right.
So now this is not a new phenomenon. This is, poisons for millennia have been tested by wise men and kings because they were worried about being poisoned. They would give themselves sublethal doses and then increase their immunity or their tolerance of it. So if someone is poisoned, they wouldn't die. And so what they went back to in their lab in France, because Portuguese man of war was hard to find, they actually changed it for a sea anemone that was in abundance in coastal France. And they called it acintotoxin. And they started trying to do these injections for tolerance in guinea pigs and pigeons, but it came back as inconclusive results, and the animals were probably too small to do it on. So they then turned to dogs.
Wow.
So they got 36 dogs, and they found their lethal dose was greater than 0.15 mil per kilogram. And so then they got a series of other dogs, and they tried to induce tolerance. However, one trial of 8 dogs received a tiny dose that wouldn't do anything to a dog, but all the 8 dogs died. And so they had to check. They died within minutes. They had to check, was the right dose given? Was this an actual massive overdose accidentally? And they confirmed it. It was not an error of the injection. It was a really small dose. They had received beforehand, so this was a second dose. So they'd been sensitized. But the results were reproducible. And so what they called this reaction was A, so Greek, they went A, which is contrary, phylaxis, so protection, so contrary protection. They ended up changing it to anaphylaxis as opposed to aphylaxis. And 1 year later, scientists were able to demonstrate that this didn't have to just be a lethal poison. This could be actually just anything they injected. So what they found was that something that had been sensitized could have a fulminant reaction that was fatal to the organism, or at this point, it was dogs. Anaphylaxis came into being.
Well, let's turn back to Dr. Daman Langguth. He's still been waiting for us to come back onto this topic of anaphylaxis. Daman, how common is anaphylaxis, especially if we separate between adults and children?
Well, we know, looking at food allergy, Australia has some of the highest rates of food allergy in children on Earth, with about 10% of infants having food allergy from Victorian data. And that data is very robust data. And that's increased, obviously, significantly and hugely over time. Of that, you're probably dealing with less than 1 in 10 of those people have anaphylaxis. So peanut allergy and milk allergy, most people don't have anaphylaxis. So it's hard to give you an exact number in the community, but I think, and most infants under age of 2 rarely have anaphylaxis. It tends to occur more in children who are older, in other words, 2 and upwards. So you're dealing with less than 1 in maybe 0.5% of the population, but probably less. Maybe 1% if you're being a health economist and you wanted money towards it, maybe 0.5%. It's just very hard to know because we don't have good data on that.
Do we have data on adults? Because I remember being very common when people would say, oh, I'm anaphylactic to penicillin when you're sort of a junior doctor going on through.
Well, even without any facts, you can say that's highly unlikely to be true.
Right. Yeah.
We know that if you look at most hospital record systems, even if they're not electronic, 13 to 20% of people claim they're allergic to penicillin. Mm. The real rate is probably kind of 0.15.
Right.
The vast majority of people's penicillin or drug reactions can be dismissed with a few simple questions. And now, actually, through research from Melbourne, a colleague of mine, Jason Trubiano, and many others have done lots of studies showing that, in fact, in most people, we don't actually need to do any testing for penicillin. We don't need to do blood testing. We don't need to do skin prick testing. We can ask 4 questions and in that decide whether we can need to go forward to testing or we can just give a naked challenge. So in other words, it's a very technical thing. You hand the person a tablet and a glass of water and they swallow it and you watch them for an hour. And it's pretty cost effective. There's no really expensive tools. Amoxicillin is pretty dirt cheap. 1 prescription can get you through 20 patients, and it's alarmingly effective. And it means that patients receive better choice of antibiotics and at lower cost to everyone in the healthcare system.
Well, now I have to ask, what are the 4 questions? Do you know them off the top of your head?
Yeah, they are. What age were you? In other words, when the reaction happened, is it more than 5 years ago? That's the same question. If it's more than 5 years ago, your chances are you don't have it anymore.
Right.
Is it, what was the reaction? So if they say my skin peeled off, that's not a good sign.
Okay.
So if it was, I can't remember, it was a bit of a rash, that doesn't count.
Yeah.
Their age, if they're, I think, older than 65, it just gives you a greater chance of, if you did have a reaction, that you might be very unwell. And I can't remember the third one, to be honest.
Oh, we'll have to link them through to the show notes. That'll be okay. I'd say I'm going to have to find out. We'll throw them out on Twitter and stuff.
Yep.
Now, can I ask then the most common cause for anaphylaxis?
It would probably be peanut in Australia.
Right. Okay. And
just because more people eat peanuts than cashews. I have found working in a private hospital and, a very high socioeconomic status patient that comes and sees me, that in fact cashews were higher. Mm. But I think that's an important thing to know, is that depending on the community you serve, that the food allergies may be different. And remember, different ethnicities eat completely different foods. Mm-hmm. As people around the world have adopted a so-called Western lifestyle, all allergies have increased. Right. So in India, chickpea allergy is actually relatively common. Mm. So chickpeas are used in India as flour. So besan flour is chickpea flour. Yeah. And they're used in place of wheat flour in lots of places. So unsurprisingly, common foods cause more allergy than uncommon foods. And there's something about some foods that there's nothing in common, but some foods are better at causing allergy than others. Tree nuts and peanuts being a classic.
Is there any risk factors, such as genetics or, your sibling has it, that may indicate they have a higher risk of anaphylaxis?
There's no evidence that anaphylaxis is hereditary. In fact, if you have anaphylaxis, it's highly unlikely your sibling will.
Right.
Wow. So as people, so sibling 1, 2, and 3, we know sibling 3 is far less likely to be atopic than sibling 1.
Right.
But we don't really know why. And that holds true across all populations. So it's not just that they avoid the foods, because often they don't.
Right.
And in fact, what it may be is that they don't avoid the foods. We know that, unfortunately, some ideas were propagated, I won't say through which countries, but it was in Australia and New Zealand, that said, the reason allergies going up, and this was in the 70s, was, we're giving kids food too early. And so they said, don't introduce foods till much later. And then the dates, which were written in the Red Book of Children, i.e. the book that every new mum and dad lives by, said that you shouldn't have egg till age 1. Now, that never had a shred of scientific evidence behind it. If you look at native cultures who do normal things with their food, only the insane would not eat egg.
Yes.
Because it's a complete food group. It's readily available. Birds produce a lot of them, and it's rich in protein. So in every single normal culture that wasn't Western, they kept doing that. And unsurprisingly, they didn't see a rise in food allergy. And in fact, in France, where the French, being typical French, said, sod off, we aren't going to do that, they did not see until much later a rise in food allergy. So their rates of nut allergy did not rise at all. Sesame did, but not, and much later. So it very much was a societal-driven thing, and some very wrong advice that was taken up and then propagated because everyone thought they were doing the right thing. Unfortunately, living in a Western lifestyle significantly reduces your risk of infection, which is fantastic. You know, that's the biggest killer of people, infection. Your first year of life, your chance of death is related to pneumonia and drinking dodgy water, which gives you various diarrheal illnesses. And that's why you die in the first year of life in the vast majority. So the minute you're not doing that, that's when your life expectancy goes up. Unfortunately, living in a Western lifestyle does seem to increase atopy, and it does increase food allergy. But the things we can do to reduce that are introduce foods early. Now, Australia actually was a world leader in that message. So that, I can't remember how many years ago, but when we said that, it was against WHO guidelines. And for WHO guidelines in food introduction are written for the third world.
Right.
Because the reason why they say don't give water to children under 1 is because that water will likely not be potable. Yeah. We do not have that problem in the West. Well, we don't have that problem in Australia and New Zealand. So, in other words, we have said for at least 6-7 years before international standards in Australia, we said foods should be introduced from 4 to 6 months. And we don't have a recommendation on how they should be introduced. My youngest child had the best food introduction that I can think of. At age 5 months, we went to Yum Cha. Right. And in the space of 2 mouthfuls of food, pretty much had every known food allergen. And I always joke because I think it's a good way of showing the cultural aspects of Australia, but it's also very good for introducing your child to new foods.
When should a patient be referred who you believe has anaphylaxis, or when is it appropriate to test? When's that the right thing to do?
Oh, look, I think anyone who has anaphylaxis deserves to see an allergist or an immunologist. They need to have an anaphylaxis action plan. They're free at allergy.org.au, which is the Australian Society of Clinical Immunology and Allergy. We've developed them for adults, for school-age children, for infants, for people with anaphylaxis, or for people who just have severe allergy, in other words, not quite anaphylaxis. Use of an EpiPen is critical. We know that the vast majority of people either do not use them or don't use them correctly. And then if you do use them, you wait too long. So basically, you should, if you think you are having anaphylaxis, or if you're not sure, and the reason you're not sure is you're worried, you use your EpiPen. And it's critical to get that in. And we know that studies show that up to 70% of people who have been trained well, who have received all the information, who have an action plan, who have an EpiPen, don't use it when they should.
On that note, let's pause because we need to come back and still have a discussion about some food allergies. Dr. Daman Langguth.
Thank you very much.
There's no light switch when you have food allergies. It's always on. It wasn't just an eating situation. It was everywhere I turned, going to a friend's house. You just have to learn to speak up and realize that if you don't, then no one else will do it for you. And it can be a matter of life or death.
Right, the final part of this episode, we're now going to focus on food allergies. And the more we've been talking, The less I'm actually feeling like having lunch after we finish recording at this point. Is this your goal?
Look, as I say, I had to study this, so this one's definitely going to turn you off your food, unfortunately.
Okay, serve it up.
All right, so this takes us to 1921. The man's name is Prasnitz, who was conducting an experiment. So again, he got a patient who had fish allergy. His name was Kastner. And he got his blood, got the serum, so the fluid part of the blood. And he got another person who was not allergic to fish, and also got their blood and the serum as well. On his own arm, he injected subcutaneously the serum, both of the fish allergic patient and the non-fish allergic patient on his arm. Then the next day, he got fish extract and injected it into the same site.
Okay.
And then he found that the patient's fish allergic area where he had injected caused a reaction. So this started a series of experimentations by other people. So in 1925, we have a doctor, a scientist by the name of Freeman. Now, he got serum of a patient who was allergic to eggs. Now, he went to a different level, which I was expecting when I read it. His middle turbinate in his nose, which now everyone knows where turbinates are because of COVID, because you try and avoid it when you're taking a nasal swab. So in the middle part of your nose, inside, were turbinates, top, middle, bottom. And he got the serum, and he injected the serum into the middle turbinate. And the following day, he ingested egg. And so he got what we call rhinitis. He sneezed, and he got a runny nose. He had a reaction. So this then takes us to over 75 years ago now, and we have Walser and colleagues in New York. And so they went a different way as opposed to experimenting on themselves, which seemed to be the vogue. They got volunteers of adults and children, and they got a list of patients who were allergic to different foods. And so things like fish and eggs. So using serum from the allergic patients, they would sensitize an area on the skin. Now, we got from Freeman that ingestion can cause
the reaction.
But then now they were going to say, well, can this happen with anyone with volunteers? So they injected an area on the skin of the volunteers, of adults and children's, and then they would feed them the food or the allergen and see what happened. 90 minutes later, about over 90% developed this large wheal or flare on the sensitized arm. So that's a positive result that whoever you're injecting on that site, it will have a reaction to that food, even ingested and then transport around. The allergen goes around the system. So then there was also where they went to colonic mucosa, so the lining of the intestine. Now, they got patients, it was 6 patients who had an ileocolostomy. So they had a segment of their bowel removed, and then they had a colostomy bag. So you can actually see some of the colonic mucosa there on their stomach, or the area where they have it, the abdomen.
Yep, my appetite completely gone.
And so what they got was the serum from these allergic patients, and they injected the colonic mucosa with that serum.
Yeah.
Then they fed the food allergen to the patients. 10 to 15 minutes later, the mucosa had gone pale, had become edematous, and had prolonged and copious amount of mucus that had been discharged from that area. So you see the effect that the food allergy can have on the colonic lining, because you can see it there. Later on, other scientists did gastroscopes, which they then would go down with the scope. They would put the allergen onto the mucosal area, the inner lining of either the stomach or the intestine, and then they went back, not long, and checked it, and there was a reaction, there was a flare to the area where the food had been placed, or the particles of the food. And so then you have a positive reaction of something that's been placed there.
All right, just before we turn to Dr. Daman again, just a thought. this Saturday night, are you interested in going to a new egg and fish restaurant that's opened up?
Probably not now.
Okay. And for the last time in this particular episode, we welcome back to the program Dr. Daman Langguth, because we want to talk about food allergies at this point. So welcome back, Daman.
Thank you very much. Glad to be here.
How common are food allergies worldwide? Let's split it between children and adults if there's a difference.
Yeah, so looking at Australia really has incredibly high rates of food allergy. Up to 10% in infants, somewhere between 6 and 8% in children, and about 2% in adults. And obviously that encompasses anaphylaxis, which is a minority, less than 10%, but significant symptoms and the need to be vigilant with foods and read food packaging, potentially for the rest of your life.
Now, I've got a list that I can see, milk, eggs, peanuts, cashews, fish, crustaceans, sesame, fruits, even mammalian meat. So it's hard to know what's the most common allergens that people will come across, GPs will come across.
So I guess we can kind of split it into groups. So infants would be milk, egg, and soy, and then peanuts as they get older towards eating solid food, and whichever food is introduced at that time. Often in Australia, crustaceans are reserved for older children. I don't know whether that's somehow it's become a cultural thing. Maybe they're too expensive, so you don't waste it on the children. It's certainly not a cultural thing in many non-Europeans. And fish often... fish allergy is quite unusual in that you can be allergic to groups of fish, all fish, or one species of fish. And we have, sadly, almost no knowledge about our own fish allergy in Australia, because it's not the same as fish allergy elsewhere. As we've seen the rise of introduction to things like sesame, we have seen increasing allergy. Sesame essentially is a nut. Seeds are the same really as nuts. They're just a different size, and we call them a different word somewhat arbitrarily. As you get older, milk allergy tends to be lost. So most children have lost milk allergy by the age of 8, and a significant number, probably most, have also lost their egg allergy. If, however, you are a small child and you have anaphylaxis to one of those foods, you are far more likely to keep it forever. If you're an adult with milk anaphylaxis, life's actually really quite difficult. Small amounts of milk are put on vast amounts of foods. It's very easy to forget that one day someone hands you a pastry, you ask, has it got milk in it? And they say no, and they forget it's had a milk brush on the surface to make the pastry shiny. Or a classic case that I have got permission to use, a patient of mine had egg anaphylaxis as a child. Now, she'd never seen a pavlova. Never seen one ever in her life, because obviously her parents steered well clear. Yeah. And she also had kiwi fruit anaphylaxis. And so one day she went round to a friend's house and they produced this sort of wondrous dessert, which she'd never seen before, and said it was pavlova. Now, she didn't even know the word because she'd never had an experience. But she knew she was allergic to kiwi fruit, and so they made a section without kiwi fruit. Now, we don't recommend that, but it's likely to be safe. So in someone with egg anaphylaxis, she hoed into the pavlova and probably had anaphylaxis.
Oh, dear.
So there's not only is it important to know which allergens cause it, but it's important to educate people on if they're avoiding these foods, where they are and what they look like. We know children under the age of 8 are not very good at discriminating nuts. So if you knock them in half, they can't tell you which one's a peanut, and that's not related to intelligence. Yeah. Just the way their visual processing system occurs. Yeah. And so they're particularly poor at telling nuts from other nuts. So you have to come up with strategies for that. Either you control how they ingest them, or you have a blanket ban that they don't eat nuts without your supervision. Because most children won't be allergic to every nut. Some are, but most will just be allergic to, say, peanut or cashew.
I'd like to ask about what the most common clinical presentations are, but I'd like to preface that by referring back to our last segment when we're talking about people self-diagnosing that they are allergic to penicillin, because there are many restaurateurs listening who seem to think that everybody's allergic to everything. Maybe there's some over self-reporting on food allergies in the general population. So if you could unpack that for us.
Unfortunately, with the rise of food allergy came the rise of food so-called sensitivities. Now, they don't really have, some of them clearly do have a scientific basis, but a lot don't. And a lot of people self-diagnose with lactose intolerance, wheat sensitivity, and in fact, there's little scientific basis. If you're European, your chance of being lactose intolerant is incredibly low, incredibly low. If you are any other culture that's not European, your chance of being lactose intolerant is incredibly high. Because, in fact, lactose intolerance is a bit unusual. People mistake it for allergy a lot, and they will often refer to it as an allergy. They're not allergists, they're people. And so that's okay, but it's really important to educate people to say, look, yeah, you'll get diarrhea, but you don't die of anaphylaxis. That certainly plenty of people claim they have all sorts of things. They kind of ruin it for the people who genuinely do. Yeah. And you do see fatigue. You see, oh, yeah, sure, you've got this. I've had patients who work in airlines, and they tell me that every day they get on the plane, someone comes up and says, oh, even if this breathes through the air, I'm going to die. And that can happen. Like, there are cases of that, but we're talking cases on Earth. Yeah. And yet, so those people kind of ruin it, unfortunately, for everybody, and you do get a bit of fatigue. I think most restaurateurs, because of the training we've had in Australia, particularly our Allergy Society, ASCIA has been very good at developing training so that people really do understand food allergy. Mm-hmm. Say, for instance, if you've eaten peanut butter and up to 2 hours later, you can have enough peanut on your lips to cause anaphylaxis in someone else if you kiss them. So those things can occur. Most people, when they're allergic to a food, ingest the food and within minutes or sometimes seconds start getting symptoms. Vomiting, rash, swollen lips, angioedema, up to 2 hours, but the vast majority we're talking about is immediate, minutes or less.
So someone says, I'm allergic, so they get vomiting and diarrhea if they have, let's say, egg. But then they can have egg. Can they progress to anaphylaxis? No,
I mean, when you're getting foods, things like vomiting and diarrhea, it can be very difficult to evaluate. Those tend to occur in younger kids, and certainly you can get type 4 hypersensitivity, which is sort of a crossover type 4, type 1, where those foods cause a reaction in the esophagus, and we call that eosinophilic esophagitis. And they often get severe abdominal pain and vomit, but they usually don't get any urticaria. That condition also occurs in adults, although the condition is more subtle and tends to present with dysphagia, the inability to swallow. But in younger children, often it's immediate vomiting. But that's not a type 1 hypersensitivity. You don't die from that. You feel bloody unwell, but you don't die. Whereas the type 1 hypersensitivity, luckily very few people come to serious harm from that, but all of that serious harm should be preventable.
On that note, Dr. Daman Langguth, thank you for being part of this episode. I think GPs listening to this, medical students, and even patients who've been listening will appreciate your down-to-earth and pragmatic way that you help us interpret and make sense of all these confusions and challenges and understanding allergies of all types. So thank you very much.
Thank you very much.
This Pathological Life is produced by ClinPath Pathology in South Australia. Episode notes, references and learning objectives, when applicable, can be found at thispathologicallife.com.au. And you can contact the hosts on Twitter via @Dr. Travis Brown or @Steve Davis. Thanks again for listening, and just a reminder, if you haven't done it yet, have a quick search in your podcast app for our second series, This Medical Life. Dr. Travis Brown has rolled up some extra guests, some extra topics, and we continue the story there, and we'd love to have you along.
Are you a podcaster? Maybe you've got that big idea and you're looking for a network to join. The multi-award-winning Ozcast network can get your content to eyes and ears all over the world. Join now for the first month free, and you could be featuring this sound at the beginning of your podcast.
Ozcast.
Simply head to ozcastnetwork.com for details.